Hello and welcome. In this video, we're going to talk about the basic circuit. So the basic circuit has two main states. It can either be open or closed. A closed circuit is one that allows current to flow through it. And we see that right here with this lamp load being on, right? If the light's on, we have current, we must have potential voltage in there as well. We can also have the switch off here, and that produces an off lamp, right? Because we've opened the pathway for current and no current can flow through there. We just have potential right up until the switch and then nothing beyond that. So we do not have any light emitting. We have no power being consumed. So we're going to call an open circuit no complete path for current flow, which means the circuit is off. A closed circuit is a complete path for current flow, meaning the circuit is on. We also sometimes need to reduce the current flow in a circuit, and we're going to use resistance to reduce current flow. Specifically, it's going to take our electrical current that we have and convert it into heat energy through our resistive loads. Any load can be represented as a resistor, so any load is going to end up getting a little warm as you run it, right? The motors heat up. Resistors will also heat up, and we'll see a couple of other components heat up quite a bit, and we have to worry about that. We have to make sure we dissipate the heat that becomes involved when we start to flow current through. We're going to measure all resistances, all loads, in terms of ohms and give it an R symbol. There are two types of main resistors. We use a lot more surface mounts now than we do wire wound, but surface mount resistors are small and have a copper base at one side that pulls electrons to the end of the resistor. They also have a flow pathway in here that allows electrons to kind of get stuck in the resistor for a little while. And on the outside, they have a resistive element and a high temperature encapsulation, which allows them to dissipate the heat that gets pulled into the resistor. Right? It consumes power that way. The wire wound resistor does basically the same thing. It has a spiral groove where the electrons can flow through, and it has our connecting leads on either end. The inside is going to have a resistive film and an insulative material that dissipates the heat for us. So the resistive film is going to reduce the flow of current, producing heat, and then the insulative material is going to pull that heat and dissipate it out. So keep in mind that heat is always a property in our electric circuits, and we need to sometimes prevent heat from causing a problem in our circuits, because too much heat can also produce an open circuit. We can burn through our components pretty quickly if we don't know that we're not supposed to get that much heat across them. All right, let us know if you have any questions.